this is your Kalpana here. So in this video we are going to find the first two moments mu1 dash mu2 dash about origin of binomial distribution. So we are going to find the first two moments of binomial distribution. Okay, so let's get started. First moment, mu1 dash equals to expectation of x. So expectation of x can be written as summation x equals to 0 to n x into p of x. Okay, here p of x is probability mass function. Probability mass function. Probability of x, capital X equals to small x, which is equals to NCR, not NCR, NCX, p power x, q power n minus x. So we are having probability mass function equals to NCX, p power x, q power n minus x. So now we'll substitute p of x. Summation x equals to 0 to n x into NCX, p power x, q power n minus x. So you would write it as x equals to 0 to n, since we know that NCX equals to n factorial by x factorial into n minus x factorial. Okay, so you'll get x into n factorial by x factorial into n minus x factorial into p power x into q power n minus x. Okay. So here you're having x. Okay. In order to cancel this x, we use x factorial. Since we know that n factorial can be written as 1 into 2 into 3 into so on, n minus 2 into n minus 1 into n. Likewise, n minus 1 factorial equals to 1 into 2 into 3 into so on, n minus 2 into n minus 1. Right? So, from this n factorial, we can take 1 into 2 into 3 into so on into n minus 1 as n minus 1 factorial, and the remaining is into n. So, you could write n factorial as n minus 1 factorial into n. Likewise, you can write x factorial as x minus 1 factorial into x, which is equals to x into x minus 1 factorial, and n factorial equals to n into n minus 1 factorial. Okay. So, this becomes summation x into, you can change this n factorial as n into n minus 1 factorial by x factorial as x into x minus 1 factorial into n minus x factorial into p power x, q power n minus x. Okay. So here you are having n minus 1 factorial and x minus 1 factorial. So we have to take summation x equals to 1 to n. For x equals to 1 to n, since we have considered x minus n minus 1 factorial and x minus 1 factorial. If you substitute x equals to 1, you will get 1 minus 1 factorial, which is 0 factorial. If x equals to 0, see, in the previous step, you have taken x equals to 0 to n, right? If x is equals to 0, then you'll get minus 1 factorial. So we should not consider x equals to 0. Since you're having x minus 1 and n minus 1 factorial, so you'll consider 1, right? That is x equals to 1 to n. Now you can cancel x and x. Okay. So here you're having n minus x factorial. So, but here you're having n minus 1 factorial in the denominator x minus 1 factorial. So you could write it as n minus 1 factorial by x minus 1 factorial into n minus x, that is n minus 1 minus x minus 1 factorial. Okay, that means you have to add minus 1 plus 1. Similarly, the powers of p, you have to add plus 1 minus 1 plus 1 minus 1. Okay. So, this n minus x minus 1 plus 1 can be written as n minus 1. Now consider these two terms and take minus common, then you'll get minus of x minus 1. Minus into minus plus 1 minus x and minus 1. Okay, which remains the same, n minus x. Okay, so we have written like this. Now you can change the step to n minus 1 minus of x minus 1 factorial. Okay, and q power n minus x plus 1 minus 1 could be written as n minus 1 minus of x minus 1. Okay, n minus 1 minus into x minus x minus into minus plus 1. Okay, so in the next step we are going to change everything in terms of n minus 1 and x minus 1. Okay, also here you are having p power x plus 1 minus 1. So you could write it as p power x minus 1 plus 1. Okay, again you can write it as p power x minus 1 into p. Fine. So this equals to summation x equals to 1 to n into, right here, n into n minus 1 factorial by x minus 1 factorial into n minus 1 minus of x minus 1 factorial. Okay, we have changed here. In this step, we have changed n minus 1 x factorial as n minus x minus 1 plus 1. Simply, we have added minus 1 and plus 1. Okay, don't get confused. Into, now you can write p power x plus 1 minus 1 as p power x minus 1 plus 1 into q power n minus x plus 1 minus 1 can be written as q power n minus 1 minus of x minus 1. Okay, so this is equals to summation x equals to 1 to n into n minus 1 factorial by x minus 1 factorial into n minus 1 minus of x minus 1 factorial p power x minus 1 into p. So p power x minus 1 plus 1 can be split into 2. P power x minus 1 into p into p power x minus 1 plus 1 can be written as p power x minus 1 into p, and q power n minus 1 minus of x minus 1 remains the same. Okay, so this is equals to, here n and p are the parameters, so you can take it outside the summation. So we'll get np into summation x equals to 1 to n minus 1 factorial by x minus 1 factorial into n minus 1 minus of x minus 1 factorial into p power x minus 1 into q power n minus 1 minus of x minus 1. Okay, if NCR equals to n factorial by x factorial into NCX, okay, if NCX equals to n factorial by x factorial into n minus x factorial, then what could be n minus 1 cx minus 1? So we can write it as n minus 1 factorial by, simply in the place of n, we'll replace n by n minus 1 and x by x minus 1 in this formula. So you'll get n minus 1 factorial by x minus 1 factorial into n. In the place of n, you have to write n minus 1 minus of, in the place of x, you have to write x minus 1 factorial. Okay. So here you are having n minus 1 factorial by x minus 1 factorial into n minus 1 minus of x minus 1 factorial. So you can replace the total expression to n minus 1 cx minus 1. Okay. This equals to np into summation x equals to 1 to n minus 1 cx minus 1 into p power x minus 1 into q power n minus 1 minus of x minus 1. By binomial theorem, we have summation r equals to 0 to n NCR into a power r into x power n minus r is equals to x plus a power n. Okay, so if you compare these two, you're having n minus 1 in the place of n, x minus 1 in the place of r. Okay, see, here also you are having r. In the place of a, you are having p. In the place of x, you are having q. So in the place of r, you are having x minus r. You can notice, right? In the place of n, in the place of r. Okay, so you could write this total expression as x plus a whole power n, that is q. In the place of x, you are having q plus, in the place of a, you are having p power n. In the place of n, you are having n minus 1. Okay. So this equals to np into q plus p power n minus 1. Since we know that p plus q equals to 1, then you could write it as np into 1 power n minus 1. 1 power n minus 1 is again 1. So you'll get np. So therefore, mu1 dash equals to mean equals to expectation of x equals to since we denote mean by x bar which is equals to expectation of x equals to NP. Okay. So the mean of the binomial distribution is NP. Okay, now coming to the second moment. So now we are going to find second moment mu2 dash equals to expectation of x square. So you could write it as summation x equals to 0 to n x square into property mass function of binomial distribution. So this is equals to summation x equals to 0 to n. So you can write x square as in terms of x into x minus 1. See, in these four moments or moments of binomial distribution will change every x power n term in terms of x into x minus 1 into x minus 2 and so on. Okay. Since we will be getting some x factorial terms, so here you will be having x minus 2, x minus 1, x minus 4, x minus 3 and all. So that we can cancel. So for that purpose we are considering x into x minus 1. Here x square can be written as x into x minus 1 plus x. See, x into x minus 1 is equals to x square minus x. Okay. If you add plus x to this, plus x minus x gets cancelled and finally you'll get x square. Okay. Or else you can see the division. X into x minus 1 which is equals to x square minus x. So if you divide x square by x square minus 1, x square minus x into 1s are x square minus x. Now change the signs. X square minus x square gets cancelled and finally you get x. Okay. So now we are going to add x square minus x plus x which is equals to x into x minus 1 plus x. Here minus x plus x cancels and finally you'll get x square. Okay. So here p of x is a probability mass function. Since p of x equals to probability capital P of x equals to ncx p power x q power n minus x. So here replace p of x with ncx p power x q power n minus x. So you could write it as summation x equals to 0 to n x into x minus 1 into ncx p power x q power n minus x plus summation x equals to 0 to n x into ncx p power x q power n minus x. Okay. Since from the first moment you are having summation x into ncx p power x into q power n minus x equals to np. So here you can replace the second term by np. Okay. So this is equals to summation x equals to 0 to n x into x minus 1. So ncx can be written as n factorial by x factorial into n minus x factorial into p power x into q power n minus x plus np. This is our mean from the first moment. Okay. So this is equals to summation x into x minus 1 into n factorial can be written as n into n minus 1 into n minus 2 factorial by x factorial can be written as x into x minus 1 into x minus 2 factorial, and n minus x factorial can be written as n minus x plus 2 minus 2. Simply we are adding plus 2 and minus 2. So you could write it as n minus 2 minus of x minus 2. Okay. If you can write it as n minus 2 minus x plus 2. From the first two you'll get n minus 2 and take minus common from the next two terms, so you'll get minus of x minus 2. Okay. So here we're having n minus x factorial, so we could write it as n minus 2 minus of x minus 2 factorial, since n minus 2 minus x plus 2 is equals to n minus x, which remains the same. So you can write it as n minus 2 into minus of, not into, minus of x minus 2 factorial. And here you're having p power x, right? The power, you can add minus 2 plus 2 into q power, you're having n minus x, right? So here also you can add minus 2 plus 2 and plus np. Okay. So this equals to, here x gets cancelled, x minus 1 gets cancelled. Since you're having x minus 2 and n minus 2 factorials, so you can change, since you're having n minus 2 factorial in the numerator and x minus 2 factorial in the denominator, sorry. So you're having minus 2. So here we should not consider x equals to 0 to n. You have to consider, you have to take x equals to, from x equals to 2 to n. Okay. Since 2 minus 2 is 0 factorial. 0 factorial is again 1. So if you take 0 for x equals to 0, you get minus 2 factorial. So you should not take x equals to 0. Since you are having in the factorial 2, that is minus 2. So we have considered x equals to 2 to n. So this equals to summation x equals to 2 to n into n minus 1 into n minus 2 factorial by x minus 2 factorial into n minus 2 minus of x minus 2 factorial into p power x minus 2 into x square can be written as p power x minus 2 into p square into q power n minus x minus 2 plus 2 can be written as n minus 2. I am taking these two first. Minus of, from these two you can take minus common and you'll get minus of x minus 2. Minus into minus plus 2 plus np. Okay. So here n minus 1 and p square, since n and p are parameters, so you can take n into n minus 1 into p square outside the summation. So you'll get n into n minus 1 into p square into summation x equals to 2 to n. If NCx can be written as n factorial by x factorial into n minus x factorial, then what could be n minus 2c x minus 2? So you can also write it as n minus 2 factorial by x minus 2 factorial into n minus 2 minus of x minus 2 factorial. Is it clear? So here we are going to replace this expression with n minus 2 c x minus 2. Since n minus 2 factorial by x minus 2 factorial to n minus 2 minus of x minus 2 factorial is equals to n minus 2 c x minus 2. Okay, into p power x minus 2. So we already took this p square outside the summation. So finally we'll get, okay, we are having q term, q power n minus 2 minus of x minus 2 plus np. Since by binomial theorem we have summation NCR a power r into x power n minus r equals to x plus a power n for r equals to 0 to n. Okay. So now using this formula you can write it as x. In the place of x you are having q, plus in the place of a you are having p, power in the place of n you are having n minus 2. So you could write it as q plus p whole power n minus 2. So this equals to n into n minus 1 into p square into q plus p whole power n minus 2 plus np. Okay, since p plus q equals to 1, so again you could write it as n into n minus 1 into p square into 1 power n minus 2 plus np. 1 power n minus 2 is again 1, so you'll get n into n minus 1 into p square plus np. Okay, so therefore mu2 dash equals to n into n minus 1 into p square plus np. Now we are going to find the variance of the binomial distribution. So variance equals to expectation of x square minus expectation of variance equals to expectation of x square minus expectation of x whole square. Since we have expectation of x square equals to, from our second moment, we have n into n minus 1 into p square plus np minus expectation of x is mean of the binomial distribution. So you can replace expectation of x by np. Okay. So n into n is n square minus n into p square plus np minus n square p square. So this equals to n square p square minus np square plus np minus n square p square. So here np square and n square p square gets cancelled. So finally this equals to minus np square plus np. So now we can take p common. You'll get minus np plus n. You could write it as, better take the positive term first, np minus np square. So now take np common. 1 minus p. We know that 1 minus p is equals to q. Since p plus q equals to 1, then 1 minus p equals to q. Or q is probability of failure. We can write it as 1 minus p. Okay. Fine. So therefore, variance of binomial distribution is npq. So we have seen the first two moments of binomial distribution in this video. Hope you will understand. We'll see you in the next video. Until then, bye bye.